Hello everyone, my name is Yuki Chihara. I'm excited to talk about our work titled by Evaluation of Regularized Best of Sampling Strategies for Language Model Alignment. So this is today's talk outline. So first of all, what is the decoder method, like best of n sampling? So I'm gonna explain like best of n sampling, which is one of the decoder methods. So the goal is to select the output with the highest reward. So beyond sampling methods is defined as this formulation. So R is a reward function. So X is a prompt. Y is output based on prompt. So YREF is a set of output from language model. So as mentioned before, based on specific prompt and considering the reward function, the goal is to select the highest reward output Y. So we assume the highest reward text assumes the highest quality text, like high quality equal high reward. So why is decoder method important? One is large language model can produce unintentionally output if we don't control. And it doesn't need to do fine tuning. It implies no need for high computational resources. So it's easy to deploy to real world applications. So, however, there are some limitations and concerns in B1 sampling. As you can see from the equation, like it's vulnerable to reward hacking and sensitive to reward function because like as you can see like it depends on the reward function quality. So reward hacking is like occurs when large language model exploit flaw in the reward function to achieve high reward in an intended way rather than like desired behavior. So to solve this limitation, so Jinnai proposed regularized BON sampling methods. There are two RBON sampling methods. One is a KL divergence form. So regularize the policy by aligning with the reference policy. So the other one was a distance using sentence similarity function. So we're gonna discuss this in detail in next slide. So the objective of album method is defined this formulation. So like the intuitive explanation is BON method plus regularizer function like KL or like what's the distance to get optimal output Y. The regularizer constraint is deterministic policy like pi Y. Under difference policy, if we put like not deterministic policy like stochastic policy, maybe the optimal output can be like not Y, like stochastic policy. So the prior method can be mitigated via hacking in experiments, but their study didn't explain like theoretical analysis or why is like regularizer effective to decode a method. So research question is arise. Like how do RBON method mitigate reward hacking? So our contributions are that we proposed stochastic RBON sampling methods with guaranteed robustness against worst case perturbation. Analyze the SRBOL method to clarify the role and the effect of regularization term. So the proposed method SRBON incorporates stochastic policy, like not deterministic policy, under regularization to enhance robustness. So the proposed method's objective function is Ajit formulation. Like it seems like prior methods, like but we mitigate the constraint like deterministic probability, the optimal output. So like the optimal output is like stochastic policy, like probability. So the difference between the proposed method and the prior methods, as mentioned earlier, like deterministic and the stochastic one. So I'm gonna explain what is like effect of relaxing the constraint. So before explaining, so we're gonna introduce like preliminaries, like convex conjugate. So what is convex conjugate? So if a regularizer function is convex, like KL divergence or like one was a distance, it can be written using its conjugate function. So like regularizer convex function can be reformulated to maximization problem with conjugate function. So what is a conjugate function? Conjugate function is defined by this formulation. Like also can be maximization problem with regularizer function. So why is this useful? We enable, we can convert our maximization problem into an equivalent minimization problem. So the short description, using the concept of convex conjugate. So SRB1 KL original problem, like this formulation, like only maximization problem. But if we use can be reformulated max min problem, like SRB1 KL problem. So we're gonna explain short proof. The objective function SRB1 KL is given by only maximization problem this time. So by applying convex conjugates, we can express KL divergence term to like maximization problem. So with conjugate function. So conjugate function is also can be reformulated maximization problem. So the above conjugate function inputs the regularizer function, like like this term, we can get the maximum formulation. So this theorem is like SRBO KL, like BON sampling plus regularizer function can be seen as maximum problem, like with delta R. So delta R like is reward perturbation, like adversarial perturbation. So this perturbation in the feasible set, like this set available to the adversarial. So intuitive is like given that R minus delta R equal R dash, like new reward. So the policy pi aim to maximize R dash while considering for range of delta R. So like new optimization program. So next discuss the SRBO and master distance. The same as SRBO and KL, SRBO and master distance can be reformulated max-min problem. So the objective function SRBON what's the distance is this formulation. So we use one what's the distance, so which can be written as a dual formulation. So one what's the distance can be maximization problem with reward perturbation. So substituting this dual form above into the original objective equation, so we can simply derive the max-min problem. So SRBON is like what's the distance is a max-min problem if we consider what's the distance dual form. So the reward perturbation delta R is like available to the adversary is bounded to this set. So intuitive is like the second term. Like first term is like same as like SRBO and KL, like optimizing reward function with considering like reward perturbation. So say, what is the second term? Can be interpreted as imposing as a constraint on the magnitude of delta R. So if we see like this adversarial set, so like delta R can be like big value, like big value. So it's too adversarial, like for reward function. So with second term is like constraint to magnitude, like how many like how big can be take reward perturbation. So the experiment result is this figure. So black is SRBO and master distance. Green one is SRBO and KL. So like SRBO and from this I can say that SRBO and master distance showed comparable performance to RBO and master distance, the blue one. Under SRB1 care, like the mismatch between the experimental setup and the theoretical envelope of R delta, like may explain the poor SRB1 care result. So it's like future work. So conclusion, we conclude that we propose a decoding method with theoretical guarantees focusing on innovative VON sampling techniques. And we explain why existing methods in prior work have been effective, providing new insights into their underlying mechanisms. So finally, the experimental results and the theoretical analysis confirm the reliability and the efficiency of our proposed methods, demonstrating their advantages over existing approaches. So thank you for listening my presentation, our research.